Hi everyone, thanks for joining us today. My name is Matt Hecox, Alliant Power Technical Information Manager. On behalf of Alliant Power, welcome to Tech Tips. Today we'll be performing the steps to diagnose and repair a 2008 Ford F-250 with the 6.4 liter Power Stroke diesel. This particular truck has come into our shop with a complaint of low power and rough running. Well, let's get to work. The tools we'll be using today are the Motorcraft IDS scan tool, a 0 to 10 psi pressure gauge, and 0 to 30 inch vacuum gauge, as well as a basic set of hand tools. To aid us in our diagnostics today, we'll be referencing a Misfire diagnostic guide created by Alliant Power. After completion of this guide, we'll have a pretty good idea of what's causing the operator's complaint. Something we always do is verify the operator's complaint with a road test. Well, I drove this truck and it definitely has low power and is running rough. So now we'll go to the diagnostic guide and follow it step by step. Step 1 is a good visual inspection of the engine compartment. We need to check our battery cables and connections, as well as our electrical harnesses and connections, our coolant hoses and connections, and we'll take a good visual inspection for any oil, fuel, or coolant leaks. Step 2 has us checking the coolant level as well as the oil level. The oil level shows on the full mark, but you want to be sure and recheck the oil by inserting the dipstick about 1 inch from being fully inserted. Now the oil level should show on the add mark, and this lets us know that the oil is not over full. If the oil is over full, that indicates that there's possibly fuel in the crankcase. In step 3, we'll inspect the exhaust system for any signs of damage. We'll also check the intake system as well as the air filter restriction gauge. Step 4 is to verify the fuel level and make sure the water and fuel light doesn't come on. We also need to remove the cap from the secondary fuel filter and check for any signs of contamination. Step 5 is checking the fuel supply pressure. But before we check the pressure, we'll look for any signs of damage or leaks at the fuel lines. Now we'll hook up the pressure gauge and verify fuel supply pressure at the fuel cooler test port. In step 6, we'll check fuel inlet restriction at the HFCM. Keep in mind that fuel pressure and fuel inlet restriction should be checked while the misfire is occurring if possible. Step 7 has us hook up the IDS scan tool and check the continuous monitor DTCs. We'll also run the key on engine off on-demand test and injector electrical test. Record any faults that are displayed. In step 8, we'll go into the data logger and check a few parameters while the engine is off. This tells us if our sensors are reading properly. Now we'll pull up a few more parameters to monitor while the engine is running. Short fuel trims are very important in diagnosing a rough running engine. They're going to help you gauge the performance of each cylinder. Step 9 has us run the key on engine running on-demand test and glow plug test. Record any DTCs that are displayed. With a cylinder misfire, you may or may not get a cylinder contribution code. In step 10, we'll verify if the PCM calibration is up to date. And it is. Step 11 is the power balance test. By simply viewing this graph, we can see that cylinder number 3 is running slower than the other cylinders. This could be caused by an injector, a valve, a piston, or any number of other problems that cause cylinder performance to be low. So now we'll run the relative compression test to try and rule out some of those issues. All the cylinders look okay. The compression on cylinder number 3 is equal to the others, leaving the injector as the most likely cause of the issue. Now we'll remove the necessary components to get to the injectors. First the air filter, then the crankcase filter, next the glow plug control module, the harness, and finally the valve cover. Now we can remove the injector. A good visual inspection may help you to determine what caused this injector to fail, such as contamination in the inlet connection. But this injector looks alright. We'll be installing a remanufactured injector from Alliant Power, part number AP64900. Once the engine's back together, don't forget to change the engine oil, filter, and fuel filters. Alliant Power always recommends changing the engine oil filter and fuel filters whenever an injector is replaced. Well, now we're ready to see how it runs. You may experience an extended crank after injector replacement. This is because of the air that's been introduced into the fuel system. It may also take up to 40 miles of driving under changing load conditions to get all the air worked out of the system, so don't be alarmed if the engine doesn't run smoothly right off the bat. After a road test, we ran the on-demand test and power balance tests again. There are no codes from the on-demand test, and our power balance looks much better. Now we can box this injector back up and return it to Alliant Power for core credit. Remember to follow each step in your diagnostic guide, and you'll have your 6.4-liter Power Stroke running like new in no time. Well, that concludes this episode of Tech Tips. Keep an eye out for new tech tips at AlliantPower.com. And on behalf of Alliant Power, thanks again for joining us today.